Hello and welcome, I'm your CodeMonkey, and here's the first video in a really interesting new format. The asset store is full of awesome assets, so I figured I could review and highlight some of the best, which can greatly help you when you're making your own games. Now for this first video in this asset review series, I chose to highlight a really special asset for me, the A-Star Pathfinding project. This is the one asset that I've used the most, and it has already helped me ship several Steam games. So here's the story. Back when I was first getting started with Unity, my very first game, Survivor Squad, was a strategy game where I really wanted to have hundreds of units, and thankfully I found this asset pretty quickly, which really helped me develop that game in a decent time frame. If I had tried to make my own custom pathfinding with support for that many units, it would have taken me ages. Whereas this was already set up with multi-threading, which made pathfinding insanely quick, even for hundreds of units. Now, you might not think that performance is all that important if you just have a handful of characters in your game, but it really is. The less time your pathfinding takes to calculate, the more time you have for other things, like more objects, more effects, to really make your game stand out. So I can definitely tell from personal experience that this is an excellent asset that will help you greatly to solve all of your pathfinding needs. And this asset is now 8 years old with non-stop constant updates. The changelog is massive, so you know this has been thoroughly battle tested in just about every scenario. As always, there's a link to the asset in the description, and that's an affiliate link, so if you pick it up through there, you'll also be helping out the channel. And as a bonus, you can use that link and then use the coupon CodeMonkey10 to get 10% off your order. So, the A-Star Pathfinding project. It's a super fast pathfinding solution. It supports dynamic scenes that are constantly changing, procedurally generated worlds, works on moving objects, easily supports elevation, works in both 2D and 3D, it's really versatile. And just like the name implies, the underlying algorithm is A-Star. If you're curious about how the algorithm works, I made a nice video going through it step by step. You can go watch that to get a better understanding, and just by looking at the very simple implementation that I do in that video and comparing it to this one, you can see how the performance difference is night and day. Now I've imported the package here, and as usual, it contains a bunch of documentation. You've got an HTML file or a PDF, and you can also find all of the updated documentation on the website. The documentation is extremely detailed, so you can really get it to work exactly as you want it. And it also comes with a total of 16 examples, so you can see it in action in pretty much every scenario imaginable. You've got simple movement, pathfinding on the terrain, one with links for jumping or a door that opens and closes, another one showing pathfinding in a procedural world, another one on a moving object, and so on. So this video is split in two parts. First, we're going to look at the demos to see what the asset can do and how they work. And then after that, I will do a quick step-by-step guide on how to start using it and add it to your own games. Let's first look at the simplest example possible, so over here on example 3. So we have this bot character, and it's following the mouse position. So I can move the mouse around, and it recalculates the path pretty much instantly. Down here on the console, we can actually see what the code is doing. So you can see how it's searching for all of these paths, searching for all of these nodes. There you go, the path length. And you also see how long it's taking, so even if I put it really far, you can see just how quickly it works. So it pretty much always rounds down to 0 milliseconds. So it's pathfinding, so obviously it goes around these objects. Then it also supports elevation, so over here we've got a ramp, and yep, it automatically knows how to get up there. And the graph can also update in real time. So I can press, as it says here, press P to place an obstacle, and I press, and there you go, drops a bunch of obstacles, and if I put it, yep, it recalculates and knows exactly where those are. All of these examples also have these useful messages teaching you how the asset works. So for example, here it's saying the A-Star game object has all the settings. If we put the game and the scene view side by side, we can see what is happening. So over there you see a gizmo for the path as it's being calculated, and you can see how fast it calculates. And just in case you don't see this graph, you can select the A-Star object, and in here make sure you have show graphs ticked. So this A-Star object contains the Pathfinder script. This is the main script with all of the parameters. The main ones are for the pathfinding area, so you can see here the width and depth in terms of voxels. And then down here you can see the size, so we can just modify this, make it smaller, hit on scan, and there you go, it makes sure that this area is walkable. You can also decrease the cell size. So doing that, it splits the area into more and more nodes, so this allows for more detailed paths. Obviously, the more detailed you go, the more time it takes to calculate. So you can manually scan by clicking here, or it will automatically scan as soon as you enter play mode. We can see how it updates in real time, so if I spawn a bunch of obstacles, yep, there you go, that's what it does. So as soon as the obstacle touches the floor, you can see, yep, it updates perfectly. So it creates a brand new nav mesh taking these positions into account. So you can play around with all of these values, then you hit on scan and make sure you've got enough of the area covered. So next up, if you scroll down here, you see the settings tab, and right away you see one of the most important ones, so the thread count. You can set it to multi-threading, which will run pathfinding pretty much without any performance cost. So if you were to use this in a final game, you'd probably choose one of these two, automatic low load or high load. Then you also see a whole bunch of debug settings. First up, the path logging, so you can make it really verbose or only show errors or don't show at all. Then you've got some graph coloring, so you can essentially visualize various different things from the path. So for example, you can set it to show the G, which is one of the parameters used in the calculation, and then up here take it to show the search tree. And if we play, yep, look at that, now we get a nice visual representation of the path as it's being calculated. So there you go, really nice, really fun to see this in action. Then you also have a whole bunch of colors that you can customize. You can give a bunch of names to the various tags. Then down here you also have saving and loading. So instead of generating the graph in runtime, you can generate it right now and then save it onto a file. And then you also have a whole bunch of optimizations. So these are for more advanced use cases. And finally you have the About tab, which showcases a whole bunch of information. The asset automatically searches for updates and lets you know if there's a new version. Alright, so that's the main pathfinding script, the Pathfinder. Now for the other important scripts, they are on the player themselves. So in this case, we have our bot character. And right away, the first one that we see is the Seeker component. This is what handles the pathfinding calls and does a bunch of post-processing on the path. Over here, you can define what graphs are traversable by this unit. And then you can also specify a bunch of tags, see if they are traversable and if they have any penalty. Then you have the AI path component. So this is a script that actually follows the path calculated by the Seeker. For the parameters, right away you can see the repath rate. So this is how often the AI will recalculate the path to the target. So the default is at 0.2, so 200 milliseconds, so 5 times per second. If you have a game that changes the pathfinding map a ton, you might want to lower this. On the other hand, if you have a very static pathfinding map, you can push this higher to make it even more performant. Then you have the various movement parameters. How it actually moves will depend on what other components you have attached to this object. For example, in this case, it has a character controller, so it's going to use that to move. If it just had a rigid body, it would use that. And if it didn't have any of those, then it would simply move the transform position directly. So all of these parameters are pretty self-explanatory. So you've got how fast it moves, a bunch of acceleration, whether it's in 2D or 3D, rotation, then how far from the final distance does it start slowing down, and how far from the final distance does it stop, should it use gravity or not, and so on. By the way, every single one of these components has a detailed explanation in the documentation. You can go into Edit Script. So here is the script for the AI path. As you can see, it's got tons and tons of comments. Then you can also go into the actual documentation to see even more information. So definitely look into that if you want to learn more about a particular component. So the AI path is the base movement script, but you don't absolutely have to use this one. You can write your own script to follow the path generated by the Seeker, but this is a great starting point. And then the post-processing that the Seeker does is dependent on the modifiers that you add onto this object. So in this case, it just has the funnel modifier. If we disable this and hit play, we can see what the original path looks like. So there you go, over there we can see the path as it's being calculated, and as I move it, yep, you can see it's very jaggy. So it's essentially only going down to the center positions of each polygon. So that's how the original path is calculated. And then if we enable funnel, yep, now you see the difference. Now it actually funnels the path and makes it into a proper path. So as I put it in there, yep, there you go, a very nice smooth path. This is just one of the included modifiers. You can go into Add Component, and then here go down into Pathfinding, and go inside the modifiers, and yep, in here you've got all of the various modifier algorithms that you can apply. And the final thing on this demo is the AI Destination Setter. This one is an extremely simple script. All it does is it grabs a reference to the AI path script, and then it goes to that one and simply sets the destination directly to this target. And the target itself is based on the mouse position. And like I said, in the second half of this video, I will go through a quick getting started guide on how to implement this from scratch. Alright, so that's the simplest example to see this asset in action. Then over here on example 4, we have an example using links. So this character has the ability to climb up, drop down, and so on. You can double click in order to set it to a certain position. So if I put it right in there, he's going to drop down from there, then he's going to make a jump, and so on. So there are links between these various pathfinding areas. And by the way, if you find the video helpful, consider subscribing and hitting the like button. It really helps out the channel. And over here on the scene view, if we select the A-star path, we take show graphs and we hit on scan, now we can visually see the links. So we can see in blue all of the walkable areas, and over here we can see the various links. So this area is linked into that one into that one, and so on. As for how the links are set up, they are set up in certain objects. So in here, if you click, you go inside the ground, inside the link, and over here you've got the various cubes. So here you got this one, so that's that floor area. And then inside it, there's a link game object. And this game object contains this animation link component. Now this is a custom component made specifically for this scenario to play the jump animation. But if you go on to add component, go down here into pathfinding, here you see link, link 2, and link 3. So these are the 3 link types that you can add, which as always, you can go check out the documentation to see how they are different. But in order to make your own link types to set up how your units handle various links, you just extend one of those types. In this case, it has this link, and then it has a child game object, which is the final position on the link. So it connects that position onto that one. Again, the documentation is extremely useful if you want to implement your own links. Then for the bot on this example, this one is using the Rich AI. So this one essentially builds on top of the simpler AI path, and that supports for the links that we see here. And then for playing the animation, it also has a script. So this example showcases how you can link various areas together. Now let's check out over here the example 5 for the point graph. This one showcases a different type of graph. So instead of a nav mesh, we've got a point graph. So this is perfect if you have a game where you want the player to only move through some specific areas. So if I put the mouse right down there, he simply goes to the closest position and never actually goes down into the void. So it always stays within the path. Again, we can inspect the path and scan it to see it in action. So this one is using a graph of type point graph, and for the root, it takes in a transform. So for the transform, if we expand this, we can see this one, and it's in here that it has all of the various nodes. So all of those nodes are child of this transform. Then on the settings for the point graph, over here we've got a max distance, so it will automatically connect all of the nodes within that distance. And beyond that, you can also add some manual links like we saw in the previous example. So for example, over here, this one and this one are too far away, so the algorithm will not automatically connect them. But if you select on this one, as you can see, there's a link component, and then it has a reference to this one. So it's manually linking both of them. So this is how you start with the automatic generation, and then you can smoothly add the things that you want. So this one is an extremely useful graph type for something like an adventure game where the player should only move through a certain path. Next up, over here on example 7, we have a door example. This one is showcasing the pathfinding updating a tag, which in this case is set for the character to not go through closed doors. So if the door is closed and I tell it to go there, nope, it doesn't go. But if I toggle the door, as soon as the door opens, yep, now he goes. Now I close it again, now I tell him to go back, nope, and as soon as I open, it does. Over here we can see the graph updating in action. The part under the door has a different color, so that's a visual representation of the tags. On the A-star object, if you go down here onto settings, onto the debug, you can see graph coloring is set to tags. So that one is set as blue, so right now it has the open door color. And if I toggle the door, yep, you can see it turns into green. So it's showcasing the different tags. Then on the bot itself, it has a seeker component. And over here, if we expand the tags, we can see how it's set up. So it's set up for the basic round, open door, and all the other tags. All of those are traversable except for the closed door. On this one, it is not traversable. And then on the door itself, it has this door control script. It has an open tag and closed tag ID. And for the script itself, down here it has a simple setState component. And what it does is it creates a graph update object. This is how you update the graph. You create this with the bounds for this object. So that's how it knows what area it should update. In this case, it's just set to modify the tag, set the tag, and it's going to set the tag to this tag. So either the open or the closed tag. So you create the graph update object, and then you call the A-star path, and you call it to update graphs and pass in the update object. So here it is in action, opening and closing, and you can see how the tag changes. And for the bot, right now I tell him to move, and it can move in here, but if I double click in there, nope, doesn't go, open the door, and now it does go. So that's how simple it is to update the graph. Then there's a second door example, and this one functionally, it works exactly the same way. So I try to go there, can't go, open the door, and now all of a sudden he goes there. If we play the scene, we can see the actual difference. So in there, we visualize the graph mesh. And right now you see that it's actually cut. So these two areas are separate. And as I open it, yep, there you go. You can see how the nav mesh constantly updates. So it's closed and now it opens. So instead of modifying tags, this one is actually modifying the underlying nav mesh. So this is a different method, and this one is using the nav mesh cut component. So here it is, constantly cutting the mesh. Then here is example 8, path types. This one showcases all of the various path types that you can use. So first of all, just a simple A to B. Then you've got a multi-target path. So this one finds the point from one position into many. Then you've got a random path, which, like the name implies, gets a random path within a certain distance. Then you've got a flee path, which essentially takes in a position and then flees away from that position. So very useful for tons of game logic. Then another one is for identifying all of the nodes within a certain range. And then on the flood path, you can search for the whole entire graph for every single node, searching from a single point. If you look in the console, you can see that this takes quite a bit of time, so it takes 10 milliseconds. However, if you cache those results, then you have pretty much free pathfinding. So if you go back into the AB path, and here as I click, if I go towards the edges, you can see that it takes between 1 and 2 milliseconds. However, if I use the flood path tracer, this one, all the paths were already calculated, so no matter how far I push it, now it's always 0 milliseconds. So that's the benefit of caching. And here you can see you have tons of ways of calculating different paths. Then on example 9, we see penalties. We have two bots. One of them absolutely cannot go through the restricted areas, and the other one tries to avoid the first area. So if I got both my bots in here, and I try to move in there you go. One of them goes all the way around, and the other one goes through there and tries to avoid touching the restricted area one as much as possible. However, if I go in here and I go down there, then he does go through the restricted area. So there's a penalty, but he can still go through it. Now, these areas are set up as tags, and they are defined in these two graph update objects. So these have the graph update scene, and over here you've got a list of all of the points. And in this case, it's set to modify a tag and set this tag. Then on this other one, it has this different shape and it applies a different tag. And finally, on the bots themselves, we can see that it's using the same thing. So on the Seeker, this one restricted area has a penalty of 300, whereas the other one is simply set to not traversable. Then on example 10, we see a layered grid graph. So this is a grid graph that also supports elevation. So on normal grid graph, which for example is the one being used here on example 9, on this one, if we set it to show the graphs and hit on scan, here we can see it's using a grid graph, and there's this slight overpass here, and you can see what happens. So it only identifies the overpass above, and it does not identify the area underneath. But if we go on to example 10, over here we have the same map, but if we go in there, we enable, we scan, and yep, now this one does identify both areas. So that's the layered grid graph. Then on example 12, we see a procedural generation. So here's the bot in a randomly generated path, and I can double click to set it to move, and as he moves, it generates more. So here I go, and if I move towards the edge of the square, as soon as it gets to a certain point, then he's going to generate a brand new area and start populating it, and so on. And if we select the pathfinding, we can see enable show graphs, and yep, you can see how it's constantly updating. So there's an area around the bot, it's constantly updating, so regardless of how the world is generated, it's always finding a path. You can even set the bot towards an area that does not exist, so the bot is going all the way up to a corner there, and as soon as he goes and he calculates the path, he sees this one is different, and then it merges with that one, and so on. So it's constantly updating. Next up, on example 15, we see a 2D example. So this one is using the XY plane instead of XZ. The obstacles themselves, they simply have a box collider 2D, so as I click, he knows exactly how to get there. And for the path, this one is using a grid graph with 2D physics and collision testing. So as I click anywhere, he knows exactly how to get there. For the AI scripts, it uses the exact same seeker, and then it can use the exact same movement script. Here it's using the AI alert for moving perfectly, but you can apply smoothing to the path or use the AI pathfinding from previously. Alright, so we've seen a whole bunch of examples. There's quite a lot more. This asset is extremely versatile and detailed. If I were to go through all of them, this video would be 1 hour long. There's tons of stuff there. But by now we've seen enough of what the asset can do, so we should be able to use it. So let's see how you could add it to your own games. Here is my demo scene with some very simple RTS controls. I made this from scratch in another video, so go check the link in the description. I can just select a whole bunch of units and tell them where to move, so very simple stuff. And on the cursor, I just have an animated cursor as just a little bit of fun. Now, as I mentioned in that video, this does not contain any pathfinding. They just blindly move towards the target position. So if I try to grow and grab that item, nope, they just ram straight towards this wall. And then there's an enemy down there, so as I click on it, instead of going all the way around, nope, they just ram towards the wall. So let's use our awesome new asset to solve our problem. So the first thing that we need is to make our A-star game object. So let's make a new game object, name it our A-star, and let's reset the transform to keep things nice and organized. Then here, let's add the component and search for the Pathfinder component. And here we expand the graphs, and now we choose what graph type we want. So in this case, this is a 2D demo, so I'm going to go with a grid graph. Then go ahead and tick on 2D, and right away we can see our graph shape. Now for node size, this is the size in units of each specific node. Naturally, this will depend on the unit size that you define for your sprites. So in my case, I'm going to put it at 5. Then you just need to extend the width and height to occupy the whole area. So as I zoom out, let's make sure it occupies the whole area. Okay, that's a good size. Then over here for the connections, we can leave it with 8 connections for each cell. So essentially it's got diagonals as well. Then make sure you tick 2D physics. Then for the collision testing, let's go with a circle with diameter of 2. And then for the layer, let's select the wall layer. So all of these wall objects, they've got box colliders and they are set to the wall layer. Alright, so that's pretty much it. And now if I hit scan, yep, there you go. Now I've got the map and it's fully working. So it identifies the walls and it identifies the walkable areas. Alright, so it's already working. Now let's make the units calculate and follow a path. For that, over here is my unit game object. Now this one is set up using the modular character controller that I made in another video. And for the movement, it's using this move position direct script. So all that does is it calculates the direction straight towards the target and sets the velocity to move towards it. So like I said, direct movement, there's no pathfinding. Now to use pathfinding, we first need to add the seeker component. So this is what actually calculates the path. Everything with default should be fine. Right now I don't want to play around with any penalties or any tags, so the default is fine. Then we add the AI path script. Again, for a more complex use case, you could extend this, but in this case, this one is more than enough. For the repath rate here, let's put it at 0.1 so it updates quickly. Then just set these values depending on the size of your sprites. So in my case, putting max speed, and then I do want them to move really quickly. So let me put with max acceleration of 500. For the orientation, this is a 2D game, so go with that one. For rotation, I don't want this game object to be rotated. For the next waypoint distance, yeah, sure, a bit more than that should be fine. For the slowdown, maybe on 10, maybe on 5. Now again, the values that I'm using here are obviously related to the size of my sprites. My 2D characters are about 3 units tall, so if you use different sprite size, then naturally you need to play around these values. Okay, so that's pretty much it. We've got the seeker to calculate the path and the AI path to follow it. All we need to do is just grab this AI path and then set the destination. So for that, let's remove the scripts that I'm using to move directly. So I'm going to remove this one that calculates the direction and this one that sets the rigid body velocity. Instead, I'm going to add this move position A* pathfinding script. Now this script is pretty much empty. All that it matters is that it implements this move position interface. So this is just how my basic unit is set to give orders towards the target move position. This unit RTS script is what listens to the player input and then just goes into whatever script implements that interface and sets the move position. So here, in order to use pathfinding, it's very simple. We just need to grab the AI path. So let's make a private AI path. And now we need the namespace. So up here, using pathfinding. So we get that, and let's say on awake, grab the path. And then on the set move position, we're simply going to set the destination towards the target move position. All right, and that's it. Just like this, it should already be working. Let's test. So here I am, and if I select it and tell it to move here, yep, there you go, it does move towards the target position. And now if I go straight towards trying to grab that item, and yep, there you go, he does go around the wall. All right, so we have pathfinding, and it is indeed working. Now if we look in the scene view, we can see what's actually happening. So we select that one, tell it to move there, and there you go, that's the calculated path. So as you can see, it's quite jaggy. So just like we saw, we can apply a modifier. So simply go down here and let's add the funnel modifier. And now if I click, yep, there you go. Now I've got a nice smooth path. So as I go there, yep, nice and smooth. So here it is. Let's take this guy, go grab that item. You go grab that item, and yep, it does work. And you go down there. Yep, he does go around it. He goes towards the enemy and shoots the enemy. All right, so yep, we have all of our logic and all of our pathfinding working. All right, awesome. So there you have it. That's how easy it is to add. You just add the pathfinding object, you set up the grid, then on the units, you add the seeker to calculate the path and a script to follow it, like the built-in AI path. The logic in 3D is exactly the same, you just use a different type of graph and change some parameters. Now you can build upon this and implement all of the features that we already saw, like the restricted areas, updating the path, elevation, and so on. So that's the A* pathfinding project. It's very easy to add, extremely fast, and works on any scenario. If you need a pathfinding solution, then this is all you need. As I said, I've already used this asset to ship successful Steam games, so I can vouch for its usefulness. Go get it through the link in the description, and as a bonus, use the coupon CodeMonkey10 to get 10% off your order. Using the affiliate link helps support the channel, and you get an awesome asset to help you in making your games. I hope you found this review useful for your own projects. Let me know in the comments any suggestions for other assets that I should review next. Thanks to these awesome Patreon supporters for making these videos possible. Thank you for watching, and I'll see you next time.